So hopefully you had an opportunity to work through this last problem with respect to the F distribution. Classroom has 4 rows of seats. The teacher wishes to determine if the mean grade for an exam is significantly different for each row. Below are the exam scores for randomly selected students in each row. So we basically have row 1, row 2, row 3, row 4. We're not saying which one's the front or the back. We just have 4 selected rows. Is there evidence to suggest there's a significant difference in the average score of the exam for each row? Null hypothesis assumes that there is no significant difference in the average scores. So we're going to say that there is no significant difference in the average score for each row. And of course the alternative is that there is a significant difference in the average score for each row. All right, just like we did before, we're going to start by figuring out N1, N2, N3, and this time N4 because there are 4 categories. So N1 is going to be 4 because notice there are 1, 2, 3, 4 observations. Right? And then same thing with row number 2. N2 is going to be 4. N3 is going to be 3, and then N4 is going to be 2 because there are 1, 2 observations. The sum of the n's, or just the big ol' N, is going to be 13. All right, and just to get that, all we did was we just added up all the n's. The totals, we're going to have 4 totals. And then we're going to have a sum of x, which is going to be the total of all the totals. So just again, I'm going to just show you how to get T1 and then that can follow suit. So T1 is 85 plus 93 plus 74 plus 100. And if we throw that in our calculator, just give me a moment. I ended up with 352. Right. And then I'll just go ahead and add the rest of them up. So 308. And if you could check these just to verify that I'm indeed correct with these, that would be appreciated. 207. And the last one's going to be 102, I believe, just by inspection. And then finally, we're just going to take all 4 of those values and we're going to add them up to get the sum of x. And I end up with 969. All right, so again, please check me just to make sure. All right, if there's an error, shoot me an email so that way I can redo this video. All right, significance levels 1%. So now we're going to find, and the number of categories K is going to be 4. Okay, because there's 4 different rows that we're looking at for this problem. So there's row 1, row 2, row 3, row 4. So that's how we get the K. And then finally, to find our F statistic, F critical, we have alpha, which is 0.01. We have degrees of freedom in the numerator, which is K minus 1, which is 3. And then finally, we have degrees of freedom in the denominator, which is N minus K. 13 minus 4 is 9. Right. So now we're going to look up the test statistic. All right, so we're going to go to 1% significance. So remember, you have to find the table, or you have to find the page first by looking at alpha is 1%. We're going to go to 3 degrees of freedom in the numerator. We're going to go to 9 degrees of freedom in the denominator. And if we verify that 6.99 should be the test statistic value. All right, and when we draw our distribution, I'm sorry, the critical value, not the test statistic, excuse me. So our F critical is 6.99. Remember the range of values for the F distribution, similar to the chi-square distribution, is going to be 0 to infinity. All right, now I'm going to copy these down because I'm going to need these. So when we start computing things, all right. And first what I'm going to do is I'm going to start by finding the SSB. All right, and I'm going to copy down those formulas. Remember we had them all the way back up here. Just to remind you guys is how to compute. I might have to erase some stuff. It's okay. All right, so let's set this up. All right, so SSB. recall that what we're going to do is we're going to compute this in two different steps. First, we're going to find this T1 square, etc. All right, so if we go back up, remember T1 was 352. So that's 352 square, and we had 4 observations. And then we had 308 square, and we had 4 observations. I think it was 207. I'll check these when I'm done. Divided by 3. And then finally, I think it was 102 square divided by 2. Now from that, we're going to subtract the sum of all the observations, which I think was 969. We're going to square that, and then we're going to divide it by the sum of the ends. In this case, I believe was 13. So let's compute each of those individually. So I'm just going to add up the 352 square over 4, etc. And just bear with me one moment. And I end up with 74177. Now from that, we're going to subtract this 969 over 13, 969 square over 13. So 969 square over 13, that's 72227. 0.769. Right, so I'm going to punch that in the calculator, and I end up with 1949.231. And we're going to hold on to that number because that's our SSB. It's one of the harder numbers to get. Now, this is where we have to do a little bit of work to get our SSW. All right, so SSW, recall, we are going to have to square every single one of those observations, and then from that we have to subtract this T1 square over N1, etc. But remember, that's the number that we just got, because that's the same thing in the formula from above. Okay, so this and this are the same thing, so no need to recompute it. We already know that's 74177. So now we're going to square each of the different observations. So that's going to be 85 square, 93 square, and I'm just going to write it out just because it might only be the second time we've done this, and that way it gives you an idea to remember how to do this, hopefully. 8063, 7573, 8054, and then 3567. And I went ahead and computed this prior to us going through and doing this just to make it a little bit more time efficient, and I wound up with the sum of all of the observations squared, or sum of, or each observation squared, sum is 75803. And from that, to get SSW, we're going to take that 75803 and we're going to subtract that 7411177, excuse me. And that's the number we got before. Remember, we computed that in blue earlier in the problem. So ultimately, when we subtract these, we should get a fairly tame number. All right, so I'm going to punch that in really quickly. 23 minus 74177, and I would with 1646 as my SSW. And essentially we're done now with the problem, because all we're going to do is we're just going to find the MSB, MSW, and then the F statistic. So let's just line these up so they're nice and set. All right. All right. And I'm going to erase all this stuff, so because that doesn't really matter anymore at this point. So we get rid of all this. All right, so SSB, remember, we got that earlier. That was this 1949.231. So that's going to be 1949.231. Forgot it already. 231. We're going to divide that by 4 minus 1, which is 3. And 649.744. So that's 649.744. Now we're going to find MSW. That's where we take that 1646 that we just got from the SSW, right? And then we're going to divide that by n minus k. Now remember, n was 13, k was 4, so 13 minus 4 is 9. And I end up with 182.889. Looks like we're going to get a a fairly big F value, maybe not big enough to reject. So finally, we're going to take this MSB, which was the 649.744. We're going to divide it by the 182.889, and I end up with 3.553. And that's our F statistic. All right. Now we're going to go ahead and we're just going to plot that on the distribution all the way back here. I knew we drew it somewhere. Did it run away? Okay. Well, remember we got 6.99. I'll just reconstruct the table really quickly. Not sure where it went, but so remember our F critical was 6.99. We had 0 to infinity. Obviously 3 is less than 6, so we have our F statistic, which is 3.553. And that just suggests that there's, again, not enough evidence to say a significant difference in the means. All right, so we're going to say, since the test value falls in the fail to reject region, there is not evidence to suggest that there is a significant difference in the mean scores based upon the row. So basically what that means is no matter what row you sit in, you're not going to have a significantly different average score. And again, this is only because there's only 13 samples. With more samples, we certainly would end up with a reject for this.